MathKlik.
Mabuhay! Do sets always have intersection? This lesson is about the set operation intersection of sets. If we want to know the elements common to two sets, we take their intersection. The intersection of two sets A and B is the set whose elements are only those which belong to set A and at the same time belong to set B. The intersection of these sets is represented by the shaded parts in the Venn diagram. And this is how we write the intersection of A and B in symbols, which is read as A intersection B. The intersection symbol also means and. Thus, A intersection B can also be read as A and B. Let us explain this set operation with examples. Again, let us use the sets A whose elements are 1, 3, 5, 7, B whose elements are 2, 4, 6, 8, and C whose elements are 3, 6, 9. To form the intersection of sets B and C, we simply put all the common elements in one set. By inspection, the element 6 is the only element common to both A and B. For A intersection B, put together all the common elements in one set. In this case, the two sets bear no common element. Thus, the intersection of these two sets is an empty set. The intersection of set B and an empty set is an empty set. Laging tandaan, wala kang makikitang common element sa pagitan ng empty at non-empty set. The intersection of set B to itself is the same as set B. Tandaan, dahil iisang set ang involved, ang intersection niya sa kanyang sarili ay yung sarili din niya. Since every set is a subset of the universal set, it follows that every element of set B is an element of the universal set. Hence, B intersection U is equal to B. Sa example naman na ito, ipapakita natin na may commutative property din na maaaring gamitin sa intersection ng sets. Let R be a set whose elements are 4, 5, and 6. Let S be a set whose element is 5. And let T be a set whose elements are 5, 6, and 7. Let's find R intersection quantity S intersection T. Simply substitute the given sets to the given expression. First, we take the intersection of sets S and T. Then, we take the intersection of R with the result of S intersection T. Thus, R intersection quantity S intersection T is the set whose element is 5. Next, we find quantity R intersection S, close quantity, intersection T. Again, we substitute the given sets to the given expression. First, we take the intersection of sets R and S. Then, we take the intersection of the result of R intersection S with T. Thus, quantity R intersection S, close quantity intersection T is the set whose element is 5. Since the two resulting sets are equal, therefore, R intersection quantity S intersection T close quantity is equal to quantity R intersection S close quantity intersection T. Now, try this. Let alpha be a set whose elements are A, B, C, and so on until the letter W. Set beta is a set whose elements are the letters F, G, H, and so on until the letter Y. What is alpha and beta? Did you get alpha intersection beta equals the set whose elements are F, G, H, and so on until W? For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!